Today we are going to be using the Pythagorean theorem to find the distance between points and to find the perimeter of an image that is on a coordinate plane. So, first, the instructions say to find the length of the line. Because the length of this line is diagonal or not going perfectly vertically or horizontally to where I could count the boxes, I have to find a different strategy to figure out this distance. Step 1 says, create a right triangle around the diagonal lines. And this means a right triangle is a triangle that has a 90-degree angle. So, I will do just that. And I have created a right triangle around this line. I could have also gone above. Now, I'm going to count the legs of the right triangle. Remember that those are the legs, and the side opposite the right angle is the hypotenuse. Our triangle that we've constructed, we're trying to find the length of the hypotenuse. And remember, we label the legs A and B, and we label the hypotenuse C always. So first I'm going to count my legs. 1, 2, 3, 4, 5, 6, 7. Step 3 says use Pythagorean theorem to find the diagonal side. So remember that the Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to write that again up here so that I can remember where to plug things in. A squared and b squared are the legs. It doesn't matter the order, so I'll just put 7 squared plus 1 squared equals c squared. 7 times 7 is 49. So I'll write that here, 49, plus 1 times 1, that's what 1 squared means, is just plus 1 equals c squared. Finally, I'm going to I'm going to add 49 and 1 to get 50. And last but not least, I need to find c by itself. I don't want c squared. I want c by itself. That'll give me the length of our missing side. So to undo a square, I square root both sides. This means that c times c, because there's 2, I circle them, 1 dies, 1 escapes, and that means I'm left with c, the one that escaped. Nothing was left on the inside, equals the square root of 50. Now the square root of 50 can be simplified, and I'll do that up here. 25 times 2 gives me 50. 2 is a prime number, so I'll circle it. 25 can be broken down into 5 times 5. Those are both prime numbers as well, so I will circle them. I'm now going to put all my prime numbers inside of my radical, and I'm going to take out pairs. So 5 and 5 create a pair. 1 dies, 1 escapes. So we'll be left with a 5 on the outside, but 2 remains on the inside because it had no pair, giving us 5 square root of 2. If I put this in my calculator, I would do so by first selecting 5, then square root can be found by clicking on 7, and then clicking on x squared, because above x squared is the square root sign. So now we have our square root. Inside our square root is 2. I'll close the parenthesis. And therefore, as a decimal, 5 square root 2 is 7.1. I'm going to round to the nearest tenths place. So 7 rounds the 0 up to 1. So 7.1. So those two answers are equivalent. In our next example, we are going to find the perimeter of the trapezoid. So we're going to have to use what we did up here in order to find the perimeter, which, if you'll remember, the perimeter is the length of the sides, or the distance around this. So I will achieve perimeter by adding up 1, 2, 3, 4 sides. And to remind myself that that's what I'm trying to do, I'm going to write 4 little boxes so that I can remember that I need to fill them in. So the first 2 boxes should be super easy because the top line of the trapezoid is horizontal. The bottom line of the trapezoid is horizontal. We can count horizontal lines by counting the boxes. So 1, 2, 3, 4. This has a length of 4, so I'll put a 4 in there. This bottom piece has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Label it on the picture, and I'll also put it in my boxes. But I still need to find these other 2. Now, just like before, I cannot count a diagonal line. I can't count the boxes. So I'm going to create a right triangle around them. There's my first one. Here's my second one. Because they have the same dimensions, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, whatever the hypotenuse is, this will be the same for this. So I only have to do this once, which is really nice. So, like we said, this part of the triangle has a distance of 4. This part of the triangle has a distance of 2. We're going to use Pythagorean theorem to find our hypotenuse. So we have 2 squared plus 4 squared equals c squared. 2 squared is 4. 4 times 4 is 16 equals c squared. 4 plus 16 is 20 equals c squared. And remember, we don't want c squared. We want c. C is the length, not c squared. So we're going to square root both sides. This gives me c by itself. And then the square root of 20 can be simplified. It's not a prime number, so I'm going to go ahead and do that over here. 4 times 5 gives me 20. 5 is a prime number, so I will circle it. 4 times 4, or 2 times 2 is 4. Those are prime numbers, so I circle them. Lastly, I put all my prime numbers inside of my radical again. I circle my pairs. This one dies, this one escapes, and this one stays on the inside. Therefore, this can be simplified to 2 square root 5. So we can put that in each of these boxes. We're first going to add them up, keeping the radicals. These 2 are like terms because they are whole numbers, so that gives me 16. These 2 are also like terms because they have the same radicand. The radicand is 5 on both, which allows me to add my coefficients. So remember, this is our radicand, and then the 2 is our coefficient. Review some vocabulary. So I'm going to add my coefficients. 2 plus 2 gives me 4. And then the square root of 5, we don't add them, we keep them as they are. So this would be my answer if I kept everything in radical form. And if I wanted to alter this into a decimal, I would go back to my calculator. I would put in 4 square root of 5, 4 square root of 5, close parenthesis, and that gives me 8.9. So again, I'm going to round to the nearest tenths place. 9 is in the tenths place. 4 keeps 9 the same. So my final answer will be 8.9. So 16 plus 8.9, so this would be 8.9, gives me, second answer, plus 16, 24.9. Again, the 4 doesn't round it up, it keeps it the same. So 24.9 is the perimeter of my trapezoid in whole numbers, in integers, and 16 plus 4 root 5 would be my answer if I kept the radicals. That would be the perimeter of this in radical form.